Lesson 4.3, Connecting Graphs of Derivatives. Good morning or afternoon. We're going to start on section 4.3 today. Tomorrow you will have a worksheet with some extra practice. I'm going to be gone tomorrow as well. So I want you to just be good for the sub. You'll have plenty to do. I'm giving you an AP practice worksheet. I'll make sure you have answers and stuff for you to check. I think the answers are actually on the worksheet on this one. So if you have questions, just remember I'll be back after break and we'll take care of you. So for today then, section 4.3, Connecting Graphs of Derivatives. Class, I'm not writing on the notebook, so my graphs and writing may be different than normal because I'm trying to do it all on my laptop. So bear with me if there's pauses or if you can't quite read things. Hopefully we'll get it figured out. The first thing I'm going to do is I'm going to draw a graph of an x cubed. So here it goes. There's my graph of an x cubed, and I also want to make some little lines here because things are going to switch right here. As I go here, I'm going to keep going down. We're going to make this long. That's supposed to be straight. And as I go here, I'm supposed to go right through that minimum that was right there. All right, so we have this graph of an x cubed. What you know about this piece of the graph right here is that it's increasing. And when it's increasing, from our t-charts, don't we know that when the graph is increasing, our derivative is positive? All right, that's something we know about this piece of the graph right here. It's increasing, which means the derivative is positive. All right, this next piece, it changes. Now we're going downhill. This graph is decreasing. And what do we know about the derivative when the graph is decreasing? That it's negative. So right here the graph is decreasing, which means the derivative is negative. Hopefully your minds are kind of at that t-chart that we've done before. At this part, once again, we are back to increasing and our derivative is positive again for this little piece right here. So we kind of have it chunked right now into groups. Now let's think about what the graph of the derivative would look like. So I'm going to graph the derivative in a different color. Our derivative will be in red. I'm going to make our x-axis. Oh, there we go. That's the x-axis right there. And so we knew here the derivative is positive, and then it's negative, and then it's positive. Since it's an x cubed, isn't the graph of our derivative going to be a little bit like an x squared? And we're going to have zeros. Right here, the derivative is 0, and right here, the derivative is 0. So at those points, we know that the graph of the derivative is going to cross right through the x-axis. So it's going to cross through right there, and then keep going, and it's going to cross back right there and keep going up. So that's supposed to kind of look like an x squared. All right, so what we notice right here is, I'm going to try to get a little bit smaller type. At this point right here is a maximum. Up there on the graph right here is a maximum. And so we know that the derivative is 0. All right, so that right at this point right here is a max right there, and so we know that the derivative is 0. And at this point, let's make it, this point right here, we have a minimum, and there the derivative is also equal to 0. Right? And so you can tell on the green graph it crosses right through and it's 0. Now what do you notice about this green graph? It's also decreasing and then increasing. And it has a derivative or slope of 0 right there. So if you think about it, this point right here is a min. It's a min of the derivative. And so doesn't that mean that the second derivative is going to equal 0? So you can see that I'm going deeper. It's like a dream inside a dream. It's a derivative inside of a derivative. We've calculated second derivatives already. So at this point right here, I don't know if I'll be able to make a point, but I'll try. At this point right here is where we have a minimum at our green graph. So it's the minimum of the derivative, which means that the second derivative is going to be 0. So I'm going to make a new little dotted line that goes right through here because on our next derivative, so now we're graphing the second derivative. So let me put something on here real quick. This guy right here is f. This guy right here is f prime. And the next graph I draw is going to be the second derivative, or f double prime. All right, so if we think about it, I wonder if I can erase on this thing. Let's see if I can. I can. Look at that. Yay, Miss Newland. Okay, except for I erased a little bit of my graph, but you know it's there. All along here, you see all those places, all along there, our derivative is decreasing. So what we know is that f prime is decreasing, and so don't we know that the second derivative is going to be negative all along here, from this space all the way to there. Here to here, the derivative is decreasing, so I know our second derivative is positive. Now over here, all along here, our derivative is increasing, and so we know that our second derivative is positive. Okay, so that's all along this place right here. So if I go to draw my second derivative, I'll choose yet another color. All right, so I'm going to make a new x-axis. Okay, that's our new x-axis. And now I'm going to draw our second derivative. Now, since this is an x squared, wouldn't the derivative of that be an x? So let me choose a different color here. So the derivative is just going to be an x, and it's got to go through right here. We have a minimum, and so our second derivative is 0. So I got to make sure and go right through that, and I'm trying to draw a straight line. That's kind of straight. And so there's our second derivative. Okay? Pretty amazing. We've got our original, our derivative, our second derivative. What do you notice about the 0 right here? This 0 right here. It was a minimum of the derivative. What point was it on our original graph? This point right here. What do we call that point? This point. It's a minimum here. It's an inflection point right here. So what I want you to notice that the inflection point of f ends up being a 0 of the second derivative. Wow. So that's something that we can actually add to our t-chart. All right, so pause it here if you guys need to stop and get any of this down or talk, have somebody come up to the class and explain. Okay. All right, then I'm going to go ahead and go on, and what we are going to do on this next slide is we are going to make bigger our t-chart. So it says on here to recall that we have an inflection point. What an inflection point is where the graph of f changes from concave up to concave down or concave down to concave up. And we know that where the derivative is increasing, the second derivative will be positive. So we're just going deeper. Remember where the f was increasing, f prime was positive? Well, now where f prime is increasing, f double prime will be positive. So let's expand our chart. I'm going to type in what we already had. In this column, we already had increasing, decreasing, max, min. Now I'm going to add concave up and concave down to it, and then we're going to add inflection point. All right, that's what we're adding. So we're expanding our t-chart. Let me scoot it over a little bit. There it is. This is now our original graph. What is going to go in our second column is positive. Remember where f is increasing, we're positive. Where f is decreasing, we're negative. Where we have a max or min, I'm going to put 0 or does not exist. Remember how in section 4.1 and 4.2 we learned that max and mins can also happen where the derivative does not exist? Then, where we're concave up, I'm going to go back to this right here. You see how here, from here to here, we're concave up. Or concave up. See that? From here to this inflection point to here, we're concave up. And what does that mean on our second derivative? We're positive. Okay. What does it mean where we're concave up on f? See how we're concave up from here to here? If you notice, we're increasing on our derivative from there to there. So concave up means increasing on the derivative, positive on the second derivative. So what I'm going to put here, I'm going to continue on with this. Whoops. is we're going to say increasing, decreasing, and then max min. Let me move that so it lines up a little better. Okay. All right. So where it's increasing, positive, decreasing, negative. We knew this already. Now, if you look back at your notes, where our original graph is concave up, we're increasing. Where our original graph is concave down, we're decreasing. And where there's an inflection point, there's a max or min. Look at it. See that inflection point right there? There's a max or min. And now let's fill in our second derivative chart. Okay, so let's fill that in. So, got to keep a couple spaces. Where there was a max or min on our original, oh, that's not going to be anything actually. Where the first graph was concave up, which means our first derivative was increasing, our second derivative is going to be positive. Where our first derivative was decreasing, we're negative, and then we have 0. Let me line this up and so you can take a look at it total here. All right. So we've expanded our t-chart a little bit. So take a look at it. Pause here and make sure everybody gets that copied down. All right, we are going to use that t-chart and our number lines to answer more questions. In the past, they ask us for critical points. They ask us for where the graph was increasing and decreasing. Now they may ask where we're concave up, concave down, or where we're an inflection point. So what we'll do, it says algebraically, what we're going to do is find where the graph is increasing, decreasing, concave up, concave down, find all the extreme values, inflection points, and then check it with the graph. So that's a lot of work we have to do. So the first example is x squared plus 7x plus 10 equals y. Now we know this is a parabola, so we could actually show with the graph everything that we're going to answer, but we're going to do all of our work algebraically. To find where it's increasing, decreasing, and max mins, don't we use the first derivative? So the first derivative would equal 2x plus 7. Agreed? All right. We want that to equal 0. And so isn't that going to be where x is equal to negative 7 halves? Oh. Okay, so we have that. So if we were to come over here and draw a number line, let's see if I can draw a number line. Pretend like this is a number line. I know it's only an arrow pointing one way. And so we would make a little mark on there, and that would be 7 halves. Okay, so that's a little mark that's 7 halves. Mark it on your sheet, even though I can't. Now when we test a number, so if you pick a number to the right of negative 7 halves, like 0, plug it into the derivative. 2 times 0 plus 7 is positive. So the graph over here is positive. And then the graph over here, if we plug in a number to the left of 7 halves, like negative 6 or something, we'd plug it in and we'd get a negative value. And so doesn't that tell us that the graph is decreasing from negative infinity to 7 halves, increasing from negative 7 halves to infinity? And if we went from decreasing to increasing, that means that this point right here is a minimum. We went from decreasing to increasing. So that point right here is a minimum. Okay? Now this is the stuff that we did in the past, and I'm not actually typing or writing all these answers. So I'm going to say it one more time. You can write it down. We are decreasing from negative infinity to negative 7 halves. We are increasing from negative 7 halves to infinity. F of negative 7 halves, which if you plug it into your original, I'll just tell you that f of negative 7 halves is negative 2.25. That is our minimum. That is our minimum. Okay, let's go ahead and come back over here and let's find the second derivative. Wouldn't the second derivative just equal 2? Okay, it just equals 2. Well, tell me about 2. It's always 2 and it's always positive. So the fact that the second derivative is always positive means that our graph, our original, is always going to be concave up. It's concave up from negative infinity to infinity. And there's no inflection point because it's always concave up. So if I wanted to answer, I'm going to try to answer this over here, but I don't think I'll be able to type everything on because we don't necessarily have math symbols like that over here. This can only do math symbols. This can only type. So we are, how do I get that to move? Here we go. Small. We are increasing from negative 7/2 to infinity. We are decreasing from infinity to negative 7/2. We have a minimum at f of negative 7/2, which equals negative 2.25. Okay. Now we also know we're concave up from negative infinity to infinity. And we have no inflection point. Oh, I can do this. Inflection point. Don't I need a negative right here? Yeah. So that would be our answers that we would say. We've answered all the questions they've asked us to. Let's look at another example. Okay, next example. F of x equals x times e to the x. Now on this one we're going to need product rule. So let's go ahead and take the derivative. The derivative of f of x is going to be the derivative of the first, 1 times the second, e to the x, and then plus the first times the derivative of the second, which is going to be e to the x. All right, that function is not, it's defined everywhere, but we can set it equal to 0. Now, how are we going to solve this? We want e to the x plus x e to the x to equal 0. How about if we factor out an e to the x? We can factor out an e to the x and then have parentheses 1 plus x. That equals 0. And then you set each one equal to 0. E to the x equals 0. Well, that can't happen. How about 1 plus x? 1 plus x can equal 0. 1 plus x equals 0 when x equals negative 1. So we have numbers to put on our number line. So this is my number line that, of course, only has one arrow. Or I'll just make it different. There's my number line. It's pointing in both directions. I want to make a little mark right here where x is negative 1. Okay, that's where x is negative 1. And now I'm going to test intervals into my derivative. Remember that this is actually f prime. So just up here, this was also f prime. Okay, so right here I'm going to test intervals, and I find out as I do this that we are negative here and that we are positive here. I'll give you a minute to kind of test that yourself. All right, so do we feel comfortable about that? Those are the intervals where it's negative and positive. So that tells us that we have, if we went from decreasing to increasing, we have a minimum again, and our minimum is f of negative 1. What happens when you plug in negative 1? You have negative 1 e to the negative 1. So wouldn't that equal maybe negative, oops. That would equal negative 1 divided by e. There's our minimum. We're decreasing from negative infinity to negative 1, and we're increasing from negative 1 to infinity. Okay. And what we're going to add on to these problems is we're going to take a look at the second derivative. So now I'm going to go ahead and put forward with the second derivative. The second derivative then is going to be, let's see, we have a couple things to take the derivative of, and we have to use product rule. The derivative of e to the x is just e to the x. And now we have plus. Now I'm going to have to use product rule, and we've done that already. So don't we know that that's also e to the x, and then plus x, plus x e to the x. All right, so we want to set that equal to 0. If you combine your like terms here, you have 2 e to the x plus x e to the x. And that equals 0. So do exactly what you did last time. I'm going to let you guys go ahead and do that. Factor out an e to the x and set it equal to 0 and see what your solutions are. All right, you should get your solution to be -2 this time. So now what we're doing is we're doing the second derivative. This is the second derivative, and the point that we have to test here on our number line is -2. So this is the second derivative. You notice how I labeled it second derivative right here. So when we go to test points, we want to make sure we test the second derivative. When you go and test and plug in numbers over here, plug in numbers over here, go do that real quick and we'll see if we get negatives or positives. Okay, did you get what I got? I had that it was negative here and positive here. So what does that mean for us? Well, if you look at your T-chart, what that means is that we have concave, our original graph is concave down from -infinity to -2. We're concave up from -2 to infinity. And what that means is that we have an inflection point. We have an inflection point because it changed concavity. Our inflection point is at -2. It's f of -2, which if you plug in -2, to our original, where is that right here? We would have -2 divided by e squared. And I can't really type math symbols over there, so that's how it would look. Okay? All right, so it's really exactly like what we were doing before, but we've just added a layer to our T-chart, which means we can answer more questions. All right, so I'd like for you to do this one more example, and I want you to either pause the tape or just work together somehow, and I want you to take a look at this example and ask all of the same questions. And I'm going to go ahead and type the answers here in just a second. All right, so those are your answers. I want you to talk as a class if you're not sure about some of those. Feel free to get help from someone else in class. And I know you all have asked me a couple times about whether or not to use parentheses or brackets on your increasing and decreasing. Books will use both hard and soft brackets on increasing and decreasing. However, you do need to use soft brackets on concavity. That's how AP wants to read those. So there's your assignment for 4-3. I want you to do the best you can. And remember that the answer key is on the podium. I'm fine if you go ahead and take a look at that if you need some help to get going. And we'll have a worksheet tomorrow. You guys have a great break.